Hey guys, I'm back. Happy Friday. It's time for another video. Today we are looking at learning target 2. Today we're going to look at some geometry applications of all of these polynomial expressions and everything. So again, see what you can do to follow along. If at any time you need to pause it and maybe try some of them on your own, I think that would be a good idea. And again, I'll be back on Monday, so we'll be able to kind of go through them and hopefully clear up any discrepancies that we may have. So if we're looking at number 1, it tells us to write an expression for both the area and the perimeter. So it's kind of up to you which one you want to do first. It doesn't really matter here. The big thing that you need to notice here is that this side on the bottom here is separated into two parts. So that means that this side is the x, and then this side right here is the 7. So best thing to think of overall is that this entire side then would be both of them together. Be careful, I tend to see a lot of people wanting to say 7 times x. But again, if the x was like 2, the whole side length would be 9, so you would just add them together. X isn't 2, we don't know what x is here. But here then that means that the whole side is x plus 7. So it doesn't matter again which one you want to find first. I'm going to go ahead and find the area first. We know that the area of a rectangle is our length times our width. So for this one, if one side of our rectangle is x plus 7, and the other side of our rectangle is 2x plus 3, we just have to multiply them. Now it doesn't matter at all which one you write first. You could write the 2x plus 3 times x plus 7. It doesn't make any difference, but we do have to recognize that we're multiplying. And then we go ahead and do our double distributing like we did in unit 1. So x times the 2x gives us the 2x squared. Then we have a plus 3x plus 14x and plus the 21. Go nice and slow so you don't make any mistakes with your adding and subtracting. I tend to do that, and you're multiplying and everything. Then combine your like terms together. We get the 2x squared plus 17x plus 21, and we just found our area. Again, nothing else we can do. We're not solving for x. We're just trying to find the area of the rectangle. Now for the perimeter. Again, if we remember that the perimeter of a rectangle, we are just adding all 4 sides together. So you can write this in one of 2 different ways on here. It doesn't really matter to me, again, which way you do it. One way you can think about it is we're just adding all 4 sides together. So we have a 2x plus 3, and we have an x plus 7. You can put them in parentheses if you want to. You don't really have to. Sometimes people like it. And then don't forget that one side is 2x plus 3. That means the other side is also 2x plus 3. And this side is also an x plus 7. So that means we have to add another 2x plus 3 and another x plus 7. I find a lot of times people really like to just do it as the perimeter formula as well. We can also think of that then as 2 times one of the sides and 2 times the other side, if you would rather think of it that way. Again, that's like twice the length plus twice the width on there. Doesn't matter to me which way you do it. Either way you get the same thing. If I think of it as the distributing the 2's here, that means both of those sides are 4x plus 6, and then this is a 2x plus 14. Combine our like terms together, or if you just combine all 4 of these x's and all 4 of the numbers together, either way you do it, you get the 6x plus 20 as our perimeter. So that's kind of a simple rectangle there. Some of the other ones get maybe a little bit more complicated. Rectangles are usually kind of the easier ones. Let's try a triangle. Now we've kind of already done some stuff with the triangles before. Again, doesn't matter which way you do it first. Let's maybe do the area first. If we remember, the area of a triangle is 1/2 times the base times the height of the triangle. Now when you're looking at the triangle, again, it doesn't matter which way the triangle is rotated here. You do have to notice though the height goes, the base and the height go from the right angle right here. So that means this side is the side I'm going to call my base, and then the perpendicular side is the height of the triangle there. So we're actually not even going to use the 5x squared plus 4 on this one. So the area, 1/2 times the base times the height. So 1/2 times the x minus 3 times the 2x squared minus 3x plus 1. So now we have to go through and actually multiply these all the way out. Take your time with this one. We've done them before, but sometimes it can be a little tricky. I usually save the 1/2 until afterwards. Remember, what we're doing is still just distributing. Now we just have to distribute a lot of it. So x times the 2x squared, we get the 2x cubed, minus the 3x squared, and then plus the 1x. Then we have to just make sure we distribute the -3 to everything. So I like to kind of put it on top of each other here. So minus the 6x squared plus the 9x minus the 3. So if you multiply all of those, we get 2x cubed, combine your like terms, minus 9x squared plus 10x and a minus 3. Don't forget, however, that we still need to multiply by the 1/2. Don't forget that part of it there. Sometimes I find I forget it, or I find a lot of people forget it. So now we can just distribute the 1/2, so we get a 1x cubed. Again, 9 times 1/2, don't get all scared off by that. That's just 9/2. And then plus 1/2 times the 10 gives us the 5x. And then the 3 times the 1/2 minus 3/2. So our area, we have to multiply it all, and then again multiply by 1/2, or think everything is divided by 2. Same idea. Perimeter, I think, is even a little bit easier with the triangle here. You just have to make sure that you are adding all the sides together. So one of the sides is the 2x squared minus 3x plus 1. You don't have to put them in parentheses. I sometimes like to separate them just so we can recognize that we added all 3 sides. Another side is the x minus 3, and then the other side is the 5x squared plus 4. Notice this time we do have to use that hypotenuse because you have to make sure you're adding all 3 sides together. You just didn't need the hypotenuse for the area because you only need the base and the height. So now just combine our like terms together. 2x squared and 5x squared give us the 7x squared. Negative 3x doesn't have a like term on there, so we just get a, oh no, we do. Sorry, we do right here. Negative 3x and the x, we get a minus 2x. And then now the 1, the negative 3, and the 4 together give us a plus 2. And we have our perimeter. All right, now that we did the area and perimeter for the rectangle and the triangle, flip it over and let's take a look at some different looking shapes here. So number 3 is still a rectangle. Notice this one, I only care about the area. I'm not looking for the perimeter. You could find some perimeters of things, but we're just going to concentrate on the area. And we just want the area of the shaded region. So when you look at it, take a minute and think about it. We just want the shaded part of it there. There's a few different ways you could go about doing it, but usually if it's both rectangles there, sometimes the easiest way to do this one is to just find the area of both of them, and then we're going to have to subtract. So I'm going to do the area of the big rectangle. I'm going to even kind of label it here. The area of the big rectangle is the length times the width, so one side is 6x minus 2, the other side is the 2x plus 1. And then we have to go through and double distribute. So we get 12x squared plus 6x minus 4x minus 2, or 12x squared plus 2x minus 2. So that's our big rectangle. Now we just have to do the smaller rectangle, or the white rectangle here. I'm going to call it small rectangle. And this one, again, one side is x, the other side is 5x plus 1. All we have to do is just regular distribute here. We get 5x squared plus 1x. Now, however, we have to find the area of the shaded region there. So to do the shaded region, we're going to have to take the big rectangle and subtract the small rectangle. So it's just a regular subtraction problem here. So the big rectangle is the 12x squared plus 2x minus 2. We're going to subtract the small, so subtract the 5x squared plus x. Now this is hands down the biggest mistake that I see. Notice I put mine in parentheses to try and avoid this mistake. The biggest mistake is to not distribute that negative part on there. So we have to make sure we distribute that negative. So it's a minus 5x squared and a minus x. That is hands down the biggest mistake. I'll say it, and I still will see people make that mistake. You want to make sure you distribute that negative there. We are subtracting the entire expression. So now we can combine our like terms together. 12x squared minus the 5x squared gives us 7x squared. And then we have a plus 1x when we combine our x's together, and then a minus 2, and that's the area of the shaded region. Notice I'm asking you one more question way down here at the bottom. What's the area of the shaded region if x equals 4? So this time I'm just giving you a numerical value for x. So we know that we have 7x squared plus x minus 2. If x equals 4, we're just plugging 4 in. 7 times 4 squared plus 4 minus 2. We get 7 times 16, or 112. And 112 plus 4 minus 2, we get 114. Now, it doesn't label it as anything. It's not inches or centimeters. We don't really know, so just square units. You can just leave it as 114 right now. All right, the last one. This one can sometimes be a little bit trickier here. So given this shape below, find the perimeter and the area. Now, we need a couple things that were not given on this, but we can find that information. We need to know the length of this side, and we need to know the length of this side right here in order to go through this problem here. So what we're going to have to do is we're going to have to find that. So if you look at it, this side right here that I have in green, and this side right here that I drew in green, the 3x plus 1, together those are both the horizontal lines. That's going to have to equal this other horizontal side. So if that whole side is 6x plus 5, this whole side also has to be 6x plus 5. So that means I have to find out what the remaining part is right here. So there's a couple ways you can do it. Some people like to do it in their head. They think 3x plus what gives us the 6x. That would be another 3x. And 1 plus what? Oops, sorry. 1 plus what number gives us the 5? So a plus 4. And that could find the other side. Some people like to just kind of go through and actually subtract. So 6x plus 5 minus the 3x plus 1. Don't forget to distribute that negative. That's how we can also get then the 3x plus 4 that goes on that side right there. Okay, so that's one way we can get this. Again, there's lots of ways to actually tackle this problem. There's a few different things you can do. I'm just going to show sometimes the most common way here. So then if we look at our verticals, I need to find this red side. This is another vertical line. Those two together have to make up this vertical side right here. So both of these have to be a 4x minus 3. Again, what we can think about is we need to think 2x plus what is going to give us the 4x. So that's going to be a 2x, because the 2x plus 2x is going to give us the 4x. And then negative 5, this one can be tougher. Negative 5 plus what will give us the negative 3? We know that would have to be a positive 2. Double check it. 2x plus 2x is 4x. 2 plus negative 5 gives us negative 3. We're good. Again, you can also do the subtraction thing. If we're going to do the 4x minus 3 minus the 2x minus 5, don't forget to distribute that negative, and then we get that, 2x, and then plus 2 that we come up with right there. So now we have all the sides. Again, there's different ways to go about this. This is not the only way to do this. If we're doing the perimeter, we are adding them all up. Again, lots of different ways to go about this. Usually what I like to do, I don't even like to write them all out. I just like to combine our like terms together. So 6x plus 2x plus 3x plus 2x plus 3x plus 4x. Altogether, there are 20 x's. And then when we look at all of our numbers, we've got a 5 plus a negative 5 plus a 4 plus a 2 plus a 1 plus a negative 3. You can use your calculator to help you also. That gives us a plus 4. We just found the perimeter. Now the area. Again, there are a lot of different ways that you can do the area, and I don't want to necessarily confuse you on it and show you a lot of the different ways, but there really are a lot of different ways that you can go about it. You can kind of treat it like you did a number 3. You can find the bigger rectangle. You could find this whole rectangle here and then subtract the smaller rectangle. That's one option for you there. You could also kind of separate these into 2 smaller rectangles and find this one and then this one together and add them together. Or you could find these 2 rectangles and then find the area of this one and the area of this one. Completely your choice. There isn't one way that's necessarily better than others on here. A lot of times I sometimes recommend the splitting it up into 2 smaller, just because I find people make less mistakes with adding the rectangles together than they do with subtracting the rectangles. But again, completely up to you. I'm going to show it that way just to show it a little bit different from what I did in number 3. If you want to pause it and try it in either of those 3 ways, it's up to you. I'm just going to show it one way, and then you can come back and you should get the same answer no matter what. I'm going to show it, and again, this is not the best way, it's just the way that I picked. I'm going to split it up into 2 rectangles here. So if I do this bigger rectangle here, I have to find the area of that. So to do the area, it's going to be the 3x plus 1 times the 4x minus 3 for that bigger rectangle. And I'm just going to do it all in one expression here. I'm going to add that to my other rectangle. Sorry, guys. Add that to the other rectangle here. If I do this one in green here, that one, the side is 3x plus 4. And then the other side is a 2x minus 5 if I'm looking at this green rectangle right here. So that's rectangles, the green one, this one is the purple one. I didn't really need the 2x plus 2 if I'm just using those 2 rectangles. So now we have to go about multiplying them and everything here. So just our normal double distributing that we would always do. So we get 12x squared minus 9x plus the 4x minus 3. And then if I add, let's just combine those like terms together. Do the same thing for the other one here, and we get 6x squared minus 15x plus 8x minus 20. Combine those like terms together, we get a minus 7x minus 20. Now combine all your like terms together. The 12x and the x squared and the 6x squared give us 18x squared. Negative 5x and negative 7x, we get the minus 12 and then minus 23. And that's, again, one way to do it. Like I said, you don't have to split it up into those separate rectangles. You could do a couple different ones. You could do it kind of how you did it in number 3. Do the whole rectangle and then subtract that corner off. You'll get the same answer either way. Again, your choice. Your choice on that one. Hopefully the video helped again. I'll be back on Monday to answer any other questions. Try these problems on the homework. You can help each other out. Again, like yesterday, I'm going to give the answer key to the homework, not so you could copy it off and check it, but at least if you're struggling, maybe they'll be able to kind of check to see where some of your answers are, okay? I'll be back on Monday to answer any questions. Happy Friday, have a good weekend, and I'll see you guys then. Bye.